Okay, hello students. I'm back with Algebra 2, Unit 2. I am illustrative mathematics, and this is lesson number 20. And the goal of this lesson is let's write and solve rational equation. That means how do we model a real world application problem into a rational equation and then solve for it and understand what is the meaning of vertical asymptote and what is the meaning of horizontal asymptote and maybe how the graph look like. So I'm going to straight away dive down to the first problem in the practice problem right here. Now again, I say this is lesson number 20. So a local office supply store charges $18 to set up their business card printing machine. So this is important information. Charges a flat charge. This is called like a one-time charge. So this is like one-time charge, or we also call it fixed amount. This is also called fixed amount, right? This is fixed amount. And then, and that this one time is for the design to have the design done. But then after that, additional 0.15, that is 15 cents, is charged per business card to print. That means so every single card will be charged additional 0.15 beside this $18. Now you're given a lot of multiple choice A, B, C, D here. So even without giving this, we should be able to create. So now here that's how it is. We have to create a rational. We have to create rational function here. So that means AX represents, so this AX represents, now this is like your Y, how we have Y equals MX plus B. So same thing that Y output the cost per per card. So the question is, you're supposed to select all the equation that could represent an expression for the average cost of printing a batch of X number of cards. So it does not talk about the total cost. So this, if it was total cost, then you will just apply this. But now he's talking about average cost per card, X business card. So that means if there are X 10 business cards, then what will be the average cost of those things, X cards? All you do is, first of all, if X cards were printed, then what will be the actual total cost? I would say this let's call this as total cost here. So the total cost will be $18, that is plus 18, which is the fixed y-intercept kind of a thing. And the slope is you're paying 0.15 dollar times the number of cards that you print. There you go. So this will be the total cost of printing X number of cards. But you want to know how much would be the cost uh, of printing X average cost of printing X number of cards. So what it means is not just total. That means you have to have a ratios of 0.15x and plus 18. This total divided by X. So it means, let's imagine, just want to understand this problem is very easy, but I want you to get this part here. Let's see if you order 100 cards, that means what this means is the average cost of printing 100 cards will be, so you put x equals 100 and you put 15 multiply by 100 and then plus 18 and then divide by 100. So basically it is also cost per each card. So average cost per each card. So that's all that means, even though they ask us for X business card, which is the cost per card. And this is how you can figure out and get the answer. So now So your so the equation is already created. So we model the real world problem into a rational equation, and then this is one of the answer. But we can always write another way, and that is if it is a plus b over c, this is same as writing a over c plus b over c. So this x which you write here can be written as 0.15x plus 18, and you can divide that to right here and divide here, and that's how you get ax becomes equals to this x, and this x crosses out and you get 0.15 plus 18 over x. So this is another way to do. And clearly you can see here when you have this part, it means x has to be greater than 0. So x cannot be equal to 0. If you write x equal to 0, that would mean the denominator. So there is a vertical asymptote here. So that is to be understood. So vertical asymptote is so the vertical asymptote is x equals 0. So that's one thing. And then there is look at this part, the end behavior, and I think we've seen this earlier. This means this whole thing, as you make X become very large, so you have, if you do large number of business cards, that means X is like the 1,000 kind of a thing, or maybe 1,000, and then you will see this, when the denominator is like a big number, the 18 over X, this 18 over X almost will be equal to 0, if not 0, but almost 0. So what are you left is for large amount of printing of cards, the average cost to print X number of cards will be almost equal to 0.15. That's it. So that means there is a horizontal asymptote here. So can I repeat? A lot of information here. Not just making this. One thing is you create is one thing, but then also understanding is as you increase the number of cards, that 18 over 100. Just imagine X is 1,000. If I put if I put X is if I put X is 1,000, this will be equal to 0.018. See, it's almost like just 2 cents here. And if I make it 10,000, that will be 0.0018. Okay, as if there's nothing. So almost like, so I hope what I'm trying to say is here there is a vertical asymptote which is x equals 0, and there is also horizontal asymptote. It means this is that y, the value of this, the cost, average cost per. Okay, I hope this takes care of whatever the information you needed. I'll just go to the second. Okay, so the second problem is the school band is in charge of a new set of uniform made with the new logo. The local business charges 140 to set up. That means this is to set up the logo itself is like a one time. So if you write the slope intercept form mx plus b, clearly this part is like 140 here. And and after that, the material per logo to be printed is 0.25. That means the slope. This is X is number of t-shirts. Uh, the uniforms, X represents the number of uniforms. There it is a X uniforms are printed, and M represents, so this will be the cost of printing. So this Y will be representing the cost. I will put it like a total cost. This is the total cost will be because each of the material with the logo is 0.25. That's the rate of change, or the slope multiplied to the number of uniforms. So this is the total, but they did the average cost per logo. That means for each one of them, and that's why they wrote CX. So it's not, it's always the total cost and divide by the X number of uniforms. So that's why we write Cx becomes equal to the total cost, which is 0.25x and plus 140, and then you divide by x. And by just looking at it, you already know, like the one that we did previous one, what is the average cost per uniform to get a logo? 25. So all you do is put 25, and you have the calculators with you. I don't want to do this. I'm just setting up this. So multiply to 25 because x is 25 now. Add 40 and divide by 40, and you get the answer. And I want you to figure out it yourself. The second time, so that's the first question. The second question, what's the average cost if it is 100 uniforms? So all you do is you replace x by 100, and that becomes 0.25 times 100 plus 40, and you just divide by 100. Of course, this question doesn't even need a calculator. You can see because there is a 100, so you can move this decimal to two places. So it becomes 25 plus 40 over 100, and this to add up to 65 over 100, and you can clearly see this. Oh, that's 140. Sorry, that's 140. So this become 165, and then you can cross this out and get 1.65. So sometimes you don't even need, but the next question is, so the question is asked, how many uniforms should be printed to have an average cost? He wants a $1. That means average cost with this equal to 1. So you just put it equal to 1. 1 means 1 over 1. So all you do is multiply x. So this will be, so both the sides we are multiplying x, multiply x, multiply x. So this x and this x crosses out, and you get 0.25x plus 140 equals x. And then you subtract 0.25 by get all the variables, get the variables on one side. This will cross out and you get 140 equals 0.75x. Then you divide by 0.75x. Okay, and then you can use your calculator, and of course you can also write this as 140, and then two zeros and divide by 75. You can do long division, but you end up getting the answer as 187 uniform. You can check, you have to show the work, and hope that takes care. The final answer is what will happen to the price as the number of uniforms. Oh God, I just cleaned the whole thing. I think, let me write this again then. So what do you think will be the price? Price is the number of uniform. So the average price. So remember the average price is 0.25x plus 140 divided by x. So we can separate this and write 0.25x divided by x, and this is plus 140 divided by x. So this x crosses out, you're left with only 0.25 and 140x, and you can clearly see, first of all, this x, there is a vertical asymptote at x equals 0 because you can't plug in x equals 0. And then when x is a very large number, this whole thing becomes very, 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 very small. So what are you left is, it will be 0.25. So as the number of uniforms printed is very large, then the average cost per uniform will be 0.25. That's all that means. And that's like y equals. So this means y is so the horizontal asymptote that I'm saying is 0.25 because that's what is going to happen. So this is going to be 0 almost. So this is what is left. So the average cost per uniform will be 0.25. That means just 25 cents. I hope that makes sense. Question number Question number 3 says two competing sports equipment suppliers sell footballs at different prices. So there is supplier A, so there is supplier A, and there is supplier B. So all you do is you create a rational function for the first one, and I call this as A, maybe AX. So you want to know how much will be the average cost per football will be. So you have to have the X number of football may be X down, AX, and because the A charges 85 in shipping, that's like fixed amount, so I'll put $85 and charges 2.59, so it is 2.59 times the number of the football. So this is the equation for the first one. But if you want to know what is the average cost per X number of ball or one average cost per ball, because the B charges $50 shipping, so that the y-intercept like a B is 50 and then charges this quite expensive 4.29. So 4.29 and X and divide by X because you want to know so average cost per football. Now, all you do is both companies are given order with 40 balls. So that means your X is 40, right? So you just have to put A of 40, A of 40, and write, okay, 2 point this multiplied by 40 plus 85. You have to write these steps. Okay? And then on the other side, you put 40 equals 4.29 times 40 plus 50 divided by X, and then figure out what is this answer, figure out this answer, and that will give you which supplier has the lowest average cost per ball. That means every single ball, which one will be the, I will put a ratio here like per ball, like the one football. For one ball, how many dollars? That's all I'm trying to say. So there will be some answer. And the same thing here also for per each ball, how many dollars? So you can use the calculator and figure out yourself. So question number 4 says, what is the one point of intersection between the graph of this and this? So if you want to know the point of intersection, all you do is put f of x equals g of x. So you have to say, okay, the f of x is x plus 6 and x plus 2 and the other one is x plus 6. So all you do is subtract both sides x plus 6 and subtract x plus 6. So that way this goes away. And on the left side, the right side will be 0 and this will be x minus 6 here. So let's write that step. And then you can clearly see this x minus 6 is the same which is multiplied. So all you do is pull it out. So undo distributive property. When you pull out the red one, what stays inside is this x plus 2 and minus, because you pull out this whole thing, there's only 1 is remaining and this whole thing is 0. Now you have x plus 6 and this will be x plus 1 equals 0, and use the zero product property and say, hey, either x plus 6 is 0 or the second parenthesis has to be 0. And you can see you just subtract 6, you get x is minus 6. So that means minus 6 common. So if you put x equals x is minus 6 and plug it in here, and it has to become 0, right? So that's 1, 0. And the other one you subtract minus 1 and get x equals minus 1. So this is, if you plug in minus 1 right here, so you will see it is minus 1 plus 6 is 5. So the point is minus 1 comma 5. So this is one point, this is another point, and then you can see which one is the option in the given problem. So I hope this also is correct, this also is correct. And so question number 5 is the graph of the polynomial given like this, and it has already intercepts. Now how do we get this intercept? We have to put this equal to 0. That means either 5x minus 3 has to be 0, or x plus 4 has to be 0, or x plus a has to be 0, right? So that means if you work this out, you get x equals 3 by 5. If you subtract 4 here, you get x equals minus 4. And this is right here. And this part is right here. And if you subtract here a, you get x is minus a. That means this part, which is the third one, minus a equals 6. So divide by minus 1, you get a is minus 6, and you're done. That's all they are checking. The function is given here, problem number 3, f of x is 3x minus 4. So if I write this, f of x is 3x minus 4, but they already did the long division method and got this answer. See, they already worked this out. In other words, they worked out like this 3x minus 4 and put x plus 6. And you say, hey, what multiplies x to get 3x? And it has to be 6, and you multiply 6 times 6 is 36, and you subtract this becomes minus and plus, you get 32. So that's the remainder. So they already gave us the remainder is oh god, I made a mistake. So this is 3, right? It should be 3, and 3 times 6 is 18 here. So this is 18 here. So you get, let me do it one more time. So just want to avoid any confusion here. So even though they gave you this, but the question is how did you get it? It's like this. You put the dividend inside, you put the divisor outside, ask a question, what multiply x to get 3x? And you can say it has to be 3, and then you multiply this, and you get 3 times 4 is uh this is 6. 6 times 3 is 18, right? So you get 18, and then you subtract. So this becomes minus 22, and that's the remainder right here. See? Okay, and this is the question. So this is the question. Now, when you look at this, the question is asking us what is the end behavior? It means when x becomes very large on x plus, let's say this is plus 6. So when x is a very large positive number, that means when x approaches to a very large positive value, so this part, or maybe x approaches to a very large negative value, what do you think will happen? So the x is down. The moment x is down, this whole thing will collapse to almost like a 0. Because the larger the denominator is, it doesn't matter, positive side or negative side. So the whole thing, this whole thing will become almost equal to 0. So this is what I left with. That means your fx will approach, the output will approach almost like 3. So, and we call it the output as y. So y will be almost approach, and that's called horizontal asymptote. I hope you understand this. And if they ask you what is the vertical asymptote, what is the vertical asymptote? Vertical asymptote is where the denominator, the points where the denominator is undefined. So the down is x plus 6, so you put denominator is 0, and x plus 6 equals 0. And you can see subtracting 6, you get x equals minus 6 is the vertical asymptote. I hope this makes sense. Okay, this completes lesson number 20, and next one I will do 21 and 22 together. And make sure you write all the steps and turn in the work.